Solving for x using logarithms in exponential form. When logs have the same base and are subtracting, you take this part and turn it into a fraction. So it'll be log base 8, 41 over x equals 5. And then from there, you're going to take it and turn it into exponential form, which is where you take the 8 and make it to the power of 5 equals 41 over x. And 8 to the 5th is 32,768. So then you're going to solve algebraically and multiply by x on both sides to get x off of the denominator. So then you have 3, 2, 7, x is 41. And then to get x by itself, you have to divide both sides by 32,768. And that comes out to x being when you divide both sides by 32,768, x comes out to be 0.001251. And then if you wanted to check your work, you could go back and plug x in at the beginning, but when you check it out, it comes out to be 5. This problem using factoring by grouping. First, the first step in factoring by grouping is you're going to look for a greatest common factor in between all the numbers. And in this case, out of all those numbers, the greatest common factor is 7n. So you're going to write 7n, and then you're going to factor out a 7n from all of those. So 84 divided by 7n is going to be 12n to the third. And then if you divide 21n to the third by 7n, you get 3n squared. And then you're going to divide 196 by 7n, and that ends up being 28n. And then you're going to divide 49 by 7n, and that just comes out as just a 7. And after that, you're going to group the numbers. So I'm going to group them like this and just make them two separate after that, you're going to see if there's a greatest common factor between the two numbers in each of the groups. And in this case, the 3 right here is the greatest common factor between the two. So you're going to write, again, you're going to write the 7n. 3n squared is the greatest common factor. 3n squared is the greatest common factor. So 12n to 7n. Alright, so from this point, we're going to look at each of the groups of numbers and see if there's a greatest common factor between the two. And so in this first group, 3n squared is going to be the greatest common factor between them. So you're going to write the 7n again, and then you're going to write a bracket to differentiate between the two different greatest common factors. So the greatest common factor here is 3n squared. So 12n cubed divided by 3n squared is going to be 4. Then 3n squared divided by 3n squared is just a 1. So you're going to end up with a 4n plus 1. And then onto this side, the greatest common factor between the two is going to be the 7. So you're going to write a 7 down, and then a parenthesis, And then 28 divided by 7 is going to be 4n. 28n divided by 7 is going to be 4n. And you gotta write a plus because you're adding them. And then you're gonna go to this number, and 7 divided by 7 is just 1. So you're just gonna get plus 1. And then another bracket. And then from here, you're gonna make it all you're gonna simplify it into one problem. And you're gonna get 7n, and then a bracket again. A parenthesis, and then you're gonna write 3n squared plus 7, because those are those two numbers, and they're just gonna end up getting added together in the end. And then in the next parenthesis, you're gonna write a 4n plus 1, because they're both 4n plus 1, so you can just multiply both by the same numbers. And so this is your final answer for factoring it. And then for your completing the square. The first step in completing the square is to get A and B by itself. So to do that, you have to add or subtract whatever C is to the other side. So then that'll cross out, and that'll be equals 854. So then you're just going to want to drop all this down, and it's 770J squared plus 1,540J equals that. And then you're going to factor out the greatest common factor if there is one. And in this instance, that is 77. So then when you rewrite it, you're just going to put 77, 10J squared plus 20J equals 854. Now, to do this, you would want to factor to solve the problem normally, but you can't factor as easily as you think. So what we're going to do is you're going to take B, which is 20, and you're going to divide it by 2, and then you're going to square it. And 20 divided by 2 is 10, so then if you square that, you're adding 100. And then you have to do that on both sides, but when you add the 100, you have to make sure to multiply it by the 77. So on this side, you're going to add 7,770. So when you add the 100, you have to make sure to multiply it by the 77 and add that much to this side. And that's 7,700. So I'm just going to add that. And we have to move it down so that there's more room. And that's going to be 8,554. And then you still have 77 parentheses 10J squared plus 20J plus 100. And then what you're going to want to do is just remember that number we found that was 10 right here. So you're going to write 77 J So what you're going to do is you're going to take this 77 and you're going to keep it on the outside, just like we have been. But then that number right here that we used, the one that gave us 100, the B divided by 2 is 10. So you're going to take J plus 10 and you're going to square it. But you're going to square the whole thing. You're not just going to square the 10. And that will give us 8,554. You do this form is how you break this down to get it easier to solve for J. So then what you're going to do is you're going to divide the whole thing by 77. On this side, cancels out. But on this side, 77 is still there. So then 1,277 does not divide into 8,554 evenly. You have to leave it as a fraction, which is 1,222 over 11. And that just gives you j plus 10 squared. Now the next thing you want to do is you want to get rid of that squared. So you're going to square root the whole thing. And that's just going to leave you with j plus 10 equals the square root of 1,222 over 11. And then you're going to subtract 10 from both sides. But what you want to do is, because we don't know if this number is negative or positive, exactly like what it is, plus or minus the square root of 1,222 over 11. And that's what you get for j. And then you can plug this number in the original equation right here, and then it will solve out to get 777.
Problem that's going to teach you how to simplify a rational. So first you're going to start off, and you want all of your denominators to be the same. So for this problem over here, you're going to have to factor. So when you factor it out, you're going to get, so you're going to have two x's, and you have to find two numbers that multiply to get 56, but also add to get 15. So those numbers in this case will be 7 and 8. So x plus 7 and x plus 8. So that's going to be your denominator over here. So now that you have this as your denominator, you have to get both of these over here to have the same denominator as that. So what you're going to do is you're going to multiply this one by x plus 8 and multiply that one by x plus 7. So I'm going to multiply x plus 8 over here and x plus 8 over here. And then I'm going to multiply x plus 7 and x plus 7. So then for this one, it's going to give me 1 over x plus 7 times x plus 8. And then I have minus x plus 8 over x minus 8. Or not over, but times x minus 8. Over x plus 7 and x plus 8. And that's going to equal x plus 7 times 1, which is just x plus 7, over x plus 7 times x plus 8. Alright, and then from here, you're going to want to get rid of your denominators so that it's an easier problem to solve. So what we're going to do is we're going to multiply this side. We're going to multiply this side by x plus 7 times x plus 8. So it cancels out this. And then we're going to multiply this side by x plus 7 times x plus 8. Multiply that, and that cancels out that. So now we've gotten rid of, cancel that as well. So now we've gotten rid of our denominators. All we're left with is our numerators. So we're going to have 1 minus x plus 8 times x minus 8 equaling x plus 7. So that's what we're going to be left with now. And now that we've gotten to this point, all we're going to do is we're going to figure out what this is. So it's going to be x squared, right here, it's going to be x squared minus 64 for this part right here. So we're done with that, and then minus 1, or plus 1, sorry. And then, so since you have a negative 64 and a plus 1, you can make it to make negative 63, obviously. And so it's going to be negative x squared minus 63 equals x plus 7. So then from there, you're going to add, to make this a positive number. Oh, that's not good. To make this a positive number, you're going to add this to both sides instead. So you have plus x squared and then plus x squared. And then you're also going to, so you're trying to get all x's on one side and all numbers on the other. You're going to take away 7 from this side and take away 7 from this side. So then you're going to be left with x squared. You're left with x squared equaling negative 70. And then so to get what x equals, you're going to have, so now you're going to have x squared plus x. So you're going to have a 2x squared that equals negative 63 minus 7. So it's going to be negative 70. Then you're going to divide both sides by 2 to get rid of the 2 on that side. And then, so it's going to be 35, or negative 35 equals x squared. And then from here, you're just going to square root both sides to get rid of that square, and square root that side. So then x is going to equal plus or minus square root of negative 35. And there's your answer. You can plug it back in at the top to see if it works out. And that's how you simplify a rational problem. What we're going to do here in this problem is we're going to find a possible function for this graph. So we're going to start out by finding out whether it's positive or negative and what the degree is. So here we're going to, this graph is negative because it starts up here in the positive. So it's starting off going to positive infinity, which means it's a negative graph. Now we're going to figure out what the degree is. And we know that the degree is an odd powered degree because it starts at positive infinity and ends at negative infinity. So they don't both go the same direction. That's how we know it's an odd powered graph. So first we're going to start off by finding out what our x-intercepts are. So first we have a negative 5, which would make it an x plus 5 in our function. So we have x plus 5. We have an x plus 2. And we're going to have a negative x squared out front, because that's also how we know, because we're going to make sure we write that it's negative. So we're going to have a negative out front. So we're going to have a negative x squared also because it bounces here. If you have a curve through, like right here, that means it's going to be to the 3rd degree. So this is going to have a 3, or any odd degree. It doesn't just have to be a 3. So we're going to have a 3 right there, which means it's going to bounce, or it's going to curve in the graph. And then here for our x plus 2, it just goes straight through, so that means we're not going to have anything there. It's not going to have a power to it. And then we're here for our negative x, we already put a squared on it because it bounces. And then for our x minus 4, we're just going to have a straight through as well, so it's not going to have any power to it. And so then we're going to continue looking at the graph, and we're going to start writing it with these x-intercepts that we have. We're going to start writing our graph. So we're going to start with our 0, so it's going to be a negative x squared, because it's a negative graph, so that's where your negative goes, and then x equals 0, and squared makes it so it's a bounce. So then after that, we're going to have a parenthesis, and we're going to have our x plus 5, because we're going to start from the left and move to the right. So we have our x plus 5, and it's to the 3rd power. So or to the third degree because it's a curve through right here. It curves through on that number. And then next we're going to have an x plus 2 because our graph intersects at the -2. And then that's a very tiny second. Okay, and then for our x squared, our x plus 2, this is not going to have any degree to it because it just goes straight through on the graph. And then last but not least, we're going to have the x minus 4. And that's not going to have a degree either because it also goes straight through. As you can see up here, these two don't have anything special to them. And that's your function right here. So if you plug this into a calculator or try to draw it, you're going to get that graph that we already have up there.